This video is in regard to the laser zone at Idea Fab Labs, Santa Cruz. It is intended to act as a beginner's lesson as well as a reference guide for you during future projects. It covers the concept of laser cutting and engraving, zone and machine safety, software that controls the machines, allowed and forbidden materials, and our cleanup protocol. Whether you've never used a laser before or are a total expert, this video will help you have success with the setup we have at Idea Fab Labs, Santa Cruz. At IFL, we have two large laser machines. Our red laser cutter has a 100 watt tube and a bed size of about 47 inches by 37 inches. This is 1200 by 900 millimeters. The gray laser has a 125 watt tube and a bed size of about 51 inches by about 35 inches. This is 1300 by 900 millimeters. Both lasers run the same software, Lightburn, and are very similar, but each have their own personality. Read the documents attached to them for specific details. The step-by-step reference and troubleshooting sheets are also extremely helpful. If you would like, you may also access the manuals and safety docs for the laser cutters on our website at santacruz.ideafablabs.com/docs. How the laser machines work. There is a glass tube filled with compressed CO2 gas in the back of the machine that, when energized, produces a laser beam. This laser is then bounced off of 45-degree mirrors and is reflected to the final mirror where the laser is concentrated to a point by a lens. The beam of the laser has an optimal focus point. You can raise or lower the bed to position your material at the ideal height. There are two primary settings that you can control: power and speed. The slower you go, the deeper the laser will cut into the material. Likewise, the higher the power, the deeper the cut. The fan pulls the smoke out and clears the cabin of small particles in the air. The chiller keeps the tube cold and makes it so that the machine does not overheat. The air pump clears debris from in front of the laser head and prevents fires. The controller is the UI of the machine, where you can start and stop jobs and move the gantry when the machine is on, among other things. There are two operations that the laser can do. It can follow paths, cutting, or it can go line by line, engraving. Laser safety. Before using the laser cutter, be sure you understand the following safety rules. These rules are in place to protect both you and the laser cutter from injury. You can cause great harm to yourself and burn the building down with these machines. If you follow the safety rules, the chance of you causing this should be close to zero. The laser beam emits radiation and can damage your eyes. Never look directly at the beam path without appropriate eye protection. Always keep the door closed during laser firing operations. Never leave the machine running while unattended. Should always be a person in the room watching the laser cutter while it is running. Human error as much as machine error often leads to unexpected outcomes. Pay attention and stop the machine whenever needed. Check to make sure that the material you are using is in the allowed list of materials. If you aren't sure, don't cut it. Never put any sort of vinyl in the laser cutter. There are 3 levels of fire condition. Small sparks, smoke, and candle-sized flames are okay, but large lingering flames are dangerous. Do not continue to cut if large flames are present. If something is barely on fire, it can likely be blown out. Pause the machine, open the door, and blow out the fire. If the fire has spread, it may need to be smothered. We have a fire blanket on hand. If there is a large fire, use the electrical fire extinguisher. Any standard fire extinguisher is a very last resort, as it will damage the machine. Fire is a huge risk to the laser and its optical and ventilation systems. If you see large flames, stop your cut immediately and switch to a lower power setting. Keep the path of the laser head clear. Before cutting, ensure that there is no risk of the lens housing colliding with any object on the honeycomb table. This could be weights, magnets, or other things that are part of your job. Please close the lid gently and do not push or jar the machine at any time. Do not lean on or press on the tray. The laser cutters are a finely calibrated piece of machinery that should not be jarred. Make sure the exhaust fan and chiller are on. Both are turned on when you start the machine. The fan operates to remove toxic fumes, and the chiller works to cool the energy moving through the laser tube. The fan must always be on while the laser is operational. If smoke is clouding the cabin of the laser, press stop or pause immediately. Always let the cabin clear of particles before opening the door. The water chiller temperature should not exceed 35 degrees. If the alarm sounds, if either does not start up or you notice smoke is not clearing out of the cabin, there is a problem. You should contact the zone manager to repair it immediately. Stop the machine and do not use it until this is done. Do not go behind the laser or attempt to perform maintenance on the laser. If there is a problem, contact the zone manager and ask for help. Do not open any of the maintenance panels or tube housing. If the tube housing is left open during operation, it can be dangerous for people in the room. Please do not turn the laser on and off repeatedly. Leave at least 5 minutes between on and off modes to allow the chiller to function properly. Getting the machine set up. Turn on the laser using the black toggle switch above the control panel. The laser will calibrate itself in the top right of the bed and return to the last origin point that was set. You can then move the head of the laser by pushing the arrow keys on the control pad in the direction that you want to go. Pressing the hand key in the center will change the speed of the head movement. This is called key speed. The default is middle. The first press will set it to high and movement will be faster. The next press will set it to low. Generally, you should keep the speed on middle. Place your material on the bed. Use guides to help align the material on the bed. These guides will help you if you need to move the piece at all, or you want to put it back where it was, or if you're doing multiples of the same job. The weights and magnets are also useful for weighing down warped pieces of material or holding down material so that it does not shift. Set your origin point. This is the top left of the job. Move the laser head to the top left of the material area and press the origin key on the laser control panel. The sounding of a long beep means the origin is set. This point corresponds to the upper leftmost corner of your work. You can move the head after you set the origin. The pause key returns the head to the origin point that you set. Set the focus height by raising or lowering the bed. Set the key speed to middle. Use the 3 and 4 buttons to raise or lower the bed so that the measuring tool, with the words readable from the side, fits smoothly between the tip of the laser head and your material. If the bed will not go in the direction that you need, follow the instructions labeled above the controller to flip the axis so you can continue. This is rare. If the measuring tool is higher than the head, you are definitely out of the focal range. The same is true if there is a lot of space between the head and the focal tool. Make sure that you test the focus at the multiple points of your material, such as the middle and the 4 corners, so that you know if there are any focusing issues or if the material or bed is not level. Other aspects of the controller: power, speed, axis control, and pulse. You can change the power, speed, and some other things on the control panel, but most of this stuff can very easily be done in the software Lightburn and should generally be done there. Be aware of the pulse button. The pulse button will fire the laser beam simply by pushing the button. If the door is open, this can be dangerous. Never push the pulse button with the door open. Some messages will show up on the bottom blue bar of the controller. If the start button is not working, there may be a message in the bar like cover protect or file mem full. See the troubleshooting guide to deal with these issues. Choosing software for artwork. There are several different software programs for creating artwork before setting it to the laser. Most common are Adobe Illustrator, CorelDRAW, Inkscape, AutoCAD, or Fusion 360. Vector-based programs are ideal as pixel-based software would only be able to do engravings and not cutting. Adobe Illustrator, Corel, and Fusion are installed on most of the shop computers for your use. Almost all vector programs will allow you to export a DXF file from them. This is the best way to open up a file inside of Lightburn. You can also directly open up Adobe Illustrator files and also PDFs. The laser has 2 main modes of operation: cutting and carving. Cuts are like vectors. Vector data is expressed via equations. When cutting, the laser moves like a plotter and follows your vector path to draw or cut them into the material. Vectors are made of a series of points along a path. Straight lines, circles, rectangles, splines, hand-drawn squiggly curves are all examples of vector data. Zooming in on a vector will never reveal pixels, no matter how far in you go. Carves, aka rosters. Roster data is made of pixels. When carving, the laser behaves similar to an inkjet printer that prints with ink, putting down dots of heat instead of ink. File types of JPG, GIF, PNG, and BMP are all examples of roster data. Images that come from your camera or scanner are also roster data. If you zoom in on roster data, you will see pixels. There are 2 modes of using the laser. It should be noted that just because you are using vector data doesn't mean you must cut through. You can lightly vector the surface of a material. Conversely, just because you are using roster data doesn't mean you can't roster completely through the material, although this can cause a fire in some materials. It is possible to carve a vector line, but it is not possible to cut a roster. Welcome to Lightburn. Lightburn is like most vector software. It has the ability to make shapes, draw lines, and manipulate those lines and shapes. It's fairly basic compared to something like Illustrator or CorelDRAW, but it's going to allow us to send instructions and settings to the laser cutter and get our job done. What you'll usually end up doing is taking something you designed in another program, such as Illustrator, and importing it into Lightburn. From here, you'll set colors, and those colors represent different things like cutting or carving into your material. Let's start by going over some of the toolbars, and then we'll import something. On the left, you'll see your basic tools: the arrow tool for selecting things, the line tool, a square or rectangle tool, an ellipse tool, polygon tool, etc. It goes on, and there's some tools you can investigate on your own time. On the top, there's your basic file menu stuff: open, save, import, undo, redo, copy, paste, some zooming and selection tools, etc. A really important one is the preview option, which we'll be using later to see how long your job is going to take and make sure that it's doing what we want it to do. Positioning and height and width are also at the top here, as well as some rotation tools, very similar to what you'd experience in another vector software program. On the right side, there's not much here yet, but this is where our different color layers are going to show up, where we'll be able to change settings like the speed and the power. You're also going to be able to control the order of operations and some other things, like which kind of operation you're going to do. Eventually we'll end up using this panel down here to send information to the laser cutter, pause it, stop it, check the boundary of what our job is, and there's even some more menus deeper here for manually moving the laser cutter from Lightburn. Let's get started by importing a vector into this program. We're going to go to the top menu and click Import. You can also go to File and choose Import from there. Let's choose this logo file. Now that the logo is placed on the field, we can zoom in with the mouse wheel, and you can see these lines we've created here. You'll also notice in the top right corner that we now have 4 different color layers that have shown up here. Like I mentioned before, each of the color layers represents a specific operation for the laser cutter. For example, you could set everything that's red to be a cut, and you could set everything that's black to be a fill engraving. These are just the colors that came with the file we created before. We can easily change them at the very bottom. There's an array of standard default colors here. You can select a line or a shape, and then you can come down and click on one of those, and the lines you have selected will have a color assigned to them. One of the settings we can change here is line to fill. You'll notice that the shape that we selected, this one here, is now filled in. When we send this to the laser cutter, it's actually going to engrave the whole shape instead of drawing the boundary. These are our 2 kinds of operations we can do: line and fill. We can also control the power and speed by double-clicking here and using this dialog window that pops up. Here's our speed control, our power settings, which we'll go into deeper, and the option to change from line to fill. Toggling this on and off by switching the output controls if this will be sent to the laser cutter or not. It dims slightly when you have turned it off. If you want to remove the whole section of your job, you can fully remove it from view by doing Show or Hide. Let's start by taking this vector and setting it up how we want. What we have on the outside is going to be our perimeter that will be cutting into the shape. The green line will be set to line, as well as these next 3. Our light bulb is going to be a fill engraving, so we'll switch this purple from line to fill. So for our lines, the external line will be a cut all the way through. These 3 lines will be slightly engraved, and the light bulb itself will be burned all the way through as a shape. Because our green line will be cutting all the way through, we're going to want to slow it down significantly, probably to about 10 if we're using 1/4 inch wood. This means the laser will cut at 10 millimeters a second. Then we'll take the power all the way up to about 60 or 70. For maximum and minimum power, you'll generally want to keep them the same. This is usually automatic, meaning that when auto is checked, the maximum and minimum power will be the same. The number of passes we'll be using is 1. Be very careful about setting this to anything but 1, because if you do, then the next person might come along and accidentally have their shape get hit 2 or 3 times. If you do change this from 1, make sure you change it back when you're finished. Here are our settings: a speed of 10 and a power of about 66. Pretty straightforward settings that will let us cut all the way through this 6mm wood material. Now let's set up an engraving. We'll start by double-clicking this color here that represents the light bulb and setting our speed to 700 and our maximum power to 60 or so. For engravings, we have to tell the laser the line interval, how many lines we're going to do within the space. These two settings here are related to each other, and if you want, you can set the lines per inch or per millimeter. 0.07 is generally a good place to start if you want a fast engraving without any dithering, meaning there will be 0.07 millimeters between each line as the laser passes. If you want it to be deeper and denser and darker, reduce the number down. You can probably go all the way down to 0.04. Anything past that will take a very long time and increase the chances of catching the piece on fire. Inversely, you can speed up your job by increasing this number up to 0.09 or 0.1. This means it will be lighter with less lines. The lines per inch will automatically set itself relative to that number, so changing one of these numbers will automatically bring the other number with it. One thing we want to do before we send our job to the laser cutter is a boundary test. On the bottom right, there's a frame with a square. This traces the cut boundary and takes everything in the file and draws a rectangle encompassing that. There's also another option in Lightburn for this frame which will actually take the shape that you're sending, and it will trace the outermost boundary points so that you can get a real look of the boundary of your work. Another thing we'll want to do before sending this out is a preview. Clicking on the preview window option at the top here will bring up this window that will show us a preview of our job. You can change the speed at which the window will demonstrate the job. Click here and it will play. Over here you can see the estimated job time. Once we're satisfied, save this out and make sure this is what you want. Be sure to check how long a job is going to take before you embark on something that might take several hours. Now that we're satisfied with what we're doing, we can send this job to the laser cutter. We can also press play and start the job from this menu here, but you should really make sure that you're ready to go before utilizing this option. Be sure that you set the focus and origin correctly. Once you hit send, you can name the file whatever you want. It is not very important as the files will get overwritten fairly often. Once your file is sent to the laser, it should show up on the control panel, and from here you can hit start. This is how you stop the laser machine. There are two good ways to stop the machine. The pause button. Use this method for convenience when you have to leave the room or just to pause the print. This is almost always the best way to stop the machine, even if it's misbehaving. The big red stop button. This will shut off the laser controller, the laser power supply, and the motors for the gantry. Use this if there's a fire or other urgent emergency. You must untwist the button to release it. The machine will not work unless you do this. The laser controller will restart at this point, causing the head to return to its machine start, and then to the origin. Thank you for taking the time to watch this video on laser cutting at Idea Fab Labs. We encourage you to regularly refer to this video to maximize your understanding and improve your ability to use this tool here. Let us know if there's anything we can do to support you. Thanks.